Section 2-4, Solving Equations, using the distributive property. Brought to you by webmathclass.com. The distributive property of multiplication. Let's do a little bit of review. If I have 3 times the quantity x plus 2, I have to distribute the 3 to both terms. So I have 3 times x plus 3 times 2, or 3x plus 6. In this case, I have negative 2 times the quantity 4x minus 3. So I have to distribute the negative 2. I have negative 2 times 4x, which is negative 8x. And then I have negative 2 times negative 3. But a negative times a negative is a positive, so negative 2 times negative 3 is positive 6. So my final answer here is negative 8x plus 6. In this case, I have the opposite of the quantity 4 minus x plus 2 times the quantity x plus 5. Well, the first thing I need to do is distribute that negative sign out front. So I have negative 4 minus a minus x, or negative 4 plus x, plus, distributing the 2, I get 2x plus 10. Now I can combine the like terms, and I have 10 minus 4 plus x plus 2x, which is 6 plus 3x, or I could rewrite that as 3x plus 6 because addition is commutative. Here's one where I have 4 times the quantity 2x squared plus x minus 2. Well, I've got to distribute that 4 to all 3 terms inside the parentheses. I have 4 times 2x squared, which is 8x squared. I have 4 times x, which is 4x. And I have 4 times negative 2, which is negative 8. So my final answer is 8x squared plus 4x minus 8. But you have to be careful. Here's a situation where I have parentheses, but I have no multiplication going on. All I'm really doing is combining like terms. I have 3x plus x is 4x, and 2 minus 1 is 1. So my answer here is 4x plus 1, and there's no distribution being undertaken at all. Here's a similar situation. I have 3x plus 2 minus the quantity x minus 1. Well, now I have to realize that that negative sign is being distributed to the second set of parentheses. So I really have 3x plus 2 minus x minus a negative 1. Or 3x plus 2 minus x plus 1, because minus a minus is a plus. Now I can combine my like terms, and I get 3x minus x is 2x. 2 plus 1 is 3. So my final answer here is 2x plus 3. Now we can solve some algebraic equations involving distribution. Here's a fairly straightforward one. 3 times the quantity x plus 2 equals 5. Well, I can start by distributing the 3. I'll have 3x plus 6 equals 5. And now I have a simple two-step equation where I can use my inverse operations to solve. Remember, doing PEMDAS backwards, first thing I'll do is undo that addition with subtraction. So I'll subtract 6 from both sides, and I get 3x equals negative 1. Now I can undo multiplication with division, dividing both sides by 3, and I get x equals negative 1/3. Remember, I should always check my answers to make sure they're correct. Plugging negative 1/3 into the original equation, I have 3 times the quantity, negative 1/3 plus 2. Well, 2 can be converted into 6/3. So I have 3 times the quantity, negative 1/3 plus 6/3, which is 5/3. 3 times 5/3 is in fact 5, and so I have the right answer. Here's another one that's a little bit more complicated. Again, we're going to start by distributing. In this case, I'm going to distribute that negative 2 to both the 5x and the negative 1, and I get negative 10x plus 2, because negative 2 times negative 1 is plus 2. And then don't forget the plus 6 equals 28. Since I've distributed, I no longer have to worry about those parentheses. Now I can combine like terms. I get negative 10x plus 8 equals 28. And again, I have a two-step equation where I can undo addition with subtraction. I'll subtract 8 from both sides. I get negative 10x equals 20. Then I'll divide both sides by negative 10 in order to undo the multiplication with division. And when I divide 20 by negative 10, I get x equals negative 2. Once again, I'll plug it into the original equation in order to check. Negative 2 times 5 times negative 2 minus 1 plus 6. Or negative 2 times, let's see, that's negative 10 minus 1 minus, and then minus some more, gives me negative 11. So negative 2 times negative 11 is positive 22, because a negative times a negative is a positive. So now I have 22 plus 6 equals 28. Yes, that's correct. Let's look at an alternative method for solving distribution equations. Here I have 4 times the quantity 3x plus 1 minus 6 equals 6. Well, instead of distributing the 4, I'm going to go ahead and use PEMDAS backwards. In this case, I have parentheses. I have multiplication because it's 4 times that quantity. And I have subtraction because of the minus 6. So I'm going to go ahead and undo these in reverse order. So the first thing I'm going to do is undo subtraction by adding 6 to both sides. And I get 4 times the quantity 3x plus 1 equals 12. At this point, I notice that 12 is divisible by 4. So rather than distributing the 4, I'm going to divide both sides by 4. And I get 3x plus 1 equals 3. The reason that I'm doing this is because 12 divided by 4 gives me a nice whole number. I don't have to work with any fractions. So I'm simply undoing multiplication with division. Now I can undo parentheses. I can subtract 1 from both sides. And I'll get 3x equals 2. And then divide both sides by 3. And I get x equals 2/3. Plugging 2/3 into the original equation, I can check my answer. 4 times the quantity, 3 times 2/3 plus 1 minus 6. That's 4 times, 3 times 2/3 is 2, plus 1 is 3. So 4 times 3 is 12, minus 6 equals 6. So yes, that is the right answer. Now I could have used the distribution method. I would have gotten the same answer. But I noticed that I could divide both sides by 4 and get a nice whole number, so I thought that would be a shortcut. Realize, however, that we had to get rid of that minus 6 first. So our first step had to be to add 6 to both sides, and then we could divide both sides by 4. We still have to do PEMDAS in reverse order. But this is a nice alternative method when the coefficient of the parentheses divides evenly into the right-hand side. Give it a try.